Bought myself a new MIG welder for Christmas. So I've never used Rohr machines before. I've only ever seen them online, and I'm very curious because they're very, very cost effective. Now I know there are a lot of people who stick to machines like Miller and Kempe and even ESAB and Lincoln. We use a lot of Lincoln machines at work at the moment. And they're all fantastic industrial brand machines. But my experience of working in welding for over 10 years now is the performance of cheap welders compared to very expensive welders. There isn't actually much of a difference. The only big difference is in build quality. But the thing is, there's been such advancements in manufacturing recently that you can actually get really cheap machines that are still built fairly well. And I feel like I've proven that already with my cheap TIG welder. It was the cheapest Chinese TIG welder I could find. I needed it for a job. And in my head, this is how I justified it. It cost me about less than a day's wage for a specific job that I needed it for. So I needed it for several days of working. So if it could pay for itself within that one day and produce several days of needing that machine, then that investment is worth it. The thing is with an industrial machine is you will pay 10 times the price. So whatever job you're needing it for, as long as you're doing 10 times the amount of work, say, is a basic mathematical equation of looking at it, then it's totally worth it. But if you're in like a hobbyist workshop, like I do work in industry, but I use works machines, so I'm used to using like a £10,000 Kempe, for example, or several £1,000 Miller machine. Those machines are fantastic. They're so reliable in their build quality and to put up with all the necessaries that industry brings. But for a workshop, especially if you're beginning at welding, or you're only doing a bit of part-time welding, you simply don't need anything that substantial. You can get away with spending very little money on a machine and do just as good stuff with it. For instance, you've seen that silly little TIG welder build the power hammer. I've used it on several other projects and it's been fantastic. It's given me all the amperage range that you could possibly need. But this is a MIG welding machine, which stands for Mechanical Inert Gas Welding Machine. And the mechanical side is that it's going to feed a spool of wire. So there are all kinds of consumables within this machine that can break quite easily. In using big industrial machines, there are things that do break over time, but they're being used constantly every single day. So I'll be very intrigued on how they've gotten this machine so cheap, because this is really cheap, and it's 200 amp as well. So that is ridiculous, absolutely ridiculous. So not only am I going to use this machine in this video, I'm going to open it up and have a look at everything inside it as well. Have a look at how it's been wired, all the different bits that can or cannot be replaced. We'll see how easy it is to maintain. Anyway, enough nattering, let's have a good look inside, shall we? Useless. If I'm happy and I leave 5-star review, I get £10 back. Kwaliteit Dutch Vorschang. Now, one of the things, as I said, it has a UK phone line that I can contact at any point, so we'll test that as well, definitely. Ask some all kinds of difficult questions, shall we? This is some sort of connection cable between... This does stick welding and MIG welding, so that's why this cable is there, I believe, to kind of link the two power systems together, I believe. A bit of spare cabling anyway. Fairly decent. standard really. It's a nice lightweight welding torch. The main thing I was interested here though is the plug connection here. I wasn't entirely sure it was a standard plug, but seeing that it is means that I can get all kinds of professional top of the line consumables, so I can get the correct leads, the ones that I like. I quite like the ones from Weld actually, and but this looks like it's fine for now. Nice and light, nice flexible hose. So far so good. Also for 200 amps I'd probably want to go up to a bigger nozzle, because these ones overheat far too much, these smaller ones. They're kind of hobbyist nozzles. But then again, I'm planning on only using very fine wire on this, so I'm not going to use anything over 0.8mm wire, but I'm actually going to use 0.6 a lot of the time for some fine MIG welding. Right. See, it's 200 amps and I've got a standard 3-pin plug. So I know it's an inverter technology in this. It starts popping fuses, you'll soon see, because I'm going to rev it up. So right here is the wire feed. This is the tensioner. So here you've got a standardized bearing. In fact, yeah, I've actually got some of those. That basically goes down, clamps onto the wire like so, and you put on tension here, not too much, not too little, and that will feed the roller in. Now behind here I can see the motor, and it looks to me like a very standard part. There's nothing here that I couldn't actually buy off the shelf right now and replace. So right here we've got like a buzz bar, if you like, a piece of copper that's going to the feed of the MIG wire, and these two are positive and negative for the stick welding capabilities. So in order to make this live, you have to link the stick welding positive to the MIG welding positive, and that's why they give you this little cable here. So on the outside you can make that. Which again, it makes things more cost effective to build. You don't have to have some complicated switching mechanism. You just supply them a little wire cable and it's sorted. There's a little button here. I don't actually know what that does. Let's see if there's anything in the manual. So absolutely nothing on the button. Here's a picture of, get in focus. So you can see everything is numbered. What's what. The button is right there, so it's actually on the picture, but no indication whatsoever of what that is. Well, we'll have to open it up and have a look, won't we? Well, we're still in shot. Let's have a look at the roller, the spool holder, should I say. So you could probably just about fit. I don't think you could actually. I'd have to get one to try, but it worked. We've got the big rolls. I think they must be like 25 kilos, so no, I think this will only take up to 5 kilos. But this is a bit tacky and a bit plasticky. Like if I tried hard enough, I could easily snap that. You've got a spring that's loose, that will go missing. Anyway, one last thing to point out here that I've looked online to see what other people's opinions were, is these plastic hinges tend to break. The good thing is they're bolted on, so if they do break, I could easily bolt on a new one. But that is a cost saving that I believe that they've put in there. Plastic hinges. This plastic handle on the top here, it actually feels fairly robust. I thought it would be quite flimsy. The moulding's not perfect on it. I'd be happy that should last a fair while. But to be honest, you drop anything heavy on this, it's going to break. Good, someone's looking after me. Anything on here that's worth concerning about? Once the contact take to give or get an electric shock, the part can cause fatal electric shock or burn. Wait a minute. Once the contact take to give or get an electric shock the part can cause the fatal electric shock or burn. Oh dear. Please not the contact to take to give or get an electric shock the part. And it's just repeated itself. Be connected by the electricity personnel is by rule weld machine and mother material ground. This is hilarious. Install when the check fixes beard close assemble electricity box power supply. Please not, that's one word, at the circumstance usage that unload the machine hole weld machine. Please the usage insulate the gloves dryly. I know I've got dyslexia, but I haven't got a clue what that just said. That is a big concern, I'd say. That is actually quite concerning. The health and safety makes no sense whatsoever. Right, so before I risk my life using this, I'm going to open it up and have a look inside and just see exactly what's going on in there. So I find this quite interesting. I've just taken the plastic outer casings off and it's still a complete machine. So that says to me that Rohr doesn't manufacture. I mean, that was obvious anyway. They don't manufacture it. They are a design company, a brand company. And so they've just taken standard off the shelf, a cheap model basically, and just slapped some stuff on it to make it look like one of their pieces. In a way, I kind of like it that the plastic comes off and you've still got a metal machine. Because that says to me, if ever the plastic cracked or smashed it by accident, it doesn't matter. I could fabricate something that would fit in. It would still work like a perfectly good machine. All I'd need to do is put some sort of a grill here. Jobs are good, and really. It's a good thing to note with MIG welders is the casing normally is earthed. So you don't want this touching any of the workpiece. So if you start welding, it'll arc into the machine and you'll probably knacker your machine up. As far as the plastic goes though, it's pretty thick. I'm not concerned about that really. I like it that I could probably rebrand this for myself actually, because I could just get it re-powder coated and put my own stamp and stuff on it, and then I've got a machine that is fine. So it's QC passed. I don't think that means a thing. Right, let's have a look at the gubbins. Well, they weren't joking when they say they use MOSFET technology, because this thing is listed with a MOSFETs, which are a kind of like a digital potentiometer essentially. You find them in drills and everything like that. So in here, I wonder if I can get you to see those. Alright, so lifting it down, right there, see there on those heat sinks, those little black things, those are MOSFETs. So we had a machine once that arced itself on one of the controllers, so making sure everything isn't touching is probably a good idea. Already I can see these capacitors here are touching a MOSFET, which isn't great. Those capacitors should be up and out of the way, but never mind. Where is it there? See that? They're all, those three pieces there are touching. That's not quite good because they do actually get quite warm. That's why they've got these little metal tabs on them. See the little metal tabs there? They are for heat sinks, and those all three of these here, the capacitors are touching. So at least that's something that I could, if that blew, I could replace those, resolder it myself. That's all I think about. How, if I fix it, can it be done? Now, interestingly, back here you've got the fan, and it says it does a 60% duty cycle, which means it can run for 6 minutes at like, what does it say here? 60% duty cycle at 200 amps. which to me is a load of rubbish, but we'll give it a test. We'll whack it up to 200 amps and see if we can use it for 6 minutes. But the good thing is there is an extra port here. You see the one that's red there? Focus. See the one that's red there? That is for the fan. There's a spare one here. So I could essentially put another fan in there and increase its duty cycle, which just means stopping it from getting overheated. Now interestingly as well, I don't know why they've done this, but you've got a main switch here, and that links to an outlet plug. See here on the back, they've actually given you an outlet for 230 volts. Well, it's 240 volts here, but and that's a European plug as well. So I don't know what they're encouraging there really. So if I have anything European and I want to use it in British territory, I can plug my welder in and then use it. So something to be noticed, as soon as I took the metal casing off, we straight away could see all of the circuitry, especially the back ends where all the pins sticking out. Now there's no insulation, there's nothing stopping this from arcing against the metal casing should things get damaged or bent or anything like that. So I'd be tempted to put like a plastic insulating board here to protect all of this from touching the outside casing, just so nothing here gets shorted. It is ground to the main structure, but I don't want these little pins and then destroying the control board and everything like that. So that's something I would add, a little sheet of insulating plastic just there. So if this, you know, that does wobble about a bit, if any fluff or dust got in here, that would be a concern of mine. As far as maintenance goes, once a year, give it a good dust out, get the airline in here. The cables are kept fairly well spaced apart. So essentially, you're going to get power 240 volts through here to then 24 volts out of these. And obviously when you've reduced the volts, you also increase the amps, and it's the amps that makes things nice and melty, which is why these cables are so thick here, but they're so thin over here. It's because they can get away with that. So interestingly enough, all of these parts that they've used, they're all branded, and they have the specs on them. So I can replace that motor, I can replace that solenoid. I would feel confident so far. So what's that switch do? So that switch is linking. The only thing that I think that switch could be is because it's linked right next door to the motor. So it might be a wire feed switch for feeding the wire through, in which case that's really helpful because you don't want to be pulling the trigger, pulling wire through, and to have the amperage all going through it as well. So to just run the motor without the amps running through it is actually a very good idea. So other than the health and safety aspect of what I've seen so far, I'm actually pretty happy. I'm really disappointed with the warning plaque that they give you. I think that's just simply not good enough. But as far as what the machine is made from and what's inside it, there's nothing there that I haven't seen before in any of the other machines that I've used, other than the MOSFETs. I'm not entirely familiar with the MOSFET technology that they're using. I don't see many of those in my other machines, but the thing, this is my reason for getting cheap machines, is to learn how to fix them yourself, to learn the electronics and the gadgetry inside it, and to be able to buy those parts comfortably off the shelf and replace those as like a technician would. I like that, but the thousands of pounds that you pay for a top brand machine, they obviously give you all the help and support there. They've got everything on the shelf, they ship it to you, there's guarantee, so it doesn't cost you anything. But this may, over time, cost me, I mean, the parts cost nothing really, but if I didn't know really what I was looking at, I'd be a bit worried about it, because once this is in your hands, I'm guessing there's no help, especially after, I mean, the warranty and all that is a load of rubbish, I think. You can argue it with Amazon and get your money back, definitely. But we'll see how it performs. We don't know what it's like yet. Right then, let's get it hooked up. Okay, so I've plugged the machine in. We're now linked to some mixed gas for MIG welding. We've got 0.8mm wire, and I bought a 5 kilogram roll, which is, I think, the largest size roll you could fit into this. You couldn't put a 10 or a 15 kilogram in here. No way, I don't think. But you could, like I said, create a separate spool and feed that through, no problem. So my curiosity is, what does this button do? So if we switch it on, so this is the first time I've run this. What does this button do? Yeah. And it's stuck. Right, so the wire just slipped off the rail here. Back on. Feel it coming through. There we are. Brilliant. So now she's live, ready to go. Okay, so we've done a few little test runs with it just to try and dial in some of the settings, and it's coming out fairly well. I think I've got it to the right balance, I think, to do this weld test. So this is 8mm thick mild steel, and this is kind of like a very similar weld test that you'd have in many different industries if you were applying for a job. So horizontal flat T-joint, I'm going to do a weld straight across, and then on the other side I'm going to do a weld, I'm going to stop in the middle and then do a restart, and then what we'll do is we'll cut all the way through and we'll etch it and see what it's doing, what it's like. Filter on. So I'd actually say it's running a bit cold. Yeah. That's blown a fuse. Hang on a moment. So what it needs is, rather than a 13 amp plug, you need a 16 amp plug, or a 32 amp plug even, with a corresponding circuit breaker, and that would give you the range that you need. As far as this side though, I did get some spray transfer. On the other side there wasn't quite enough amps, I think, because I've gone that much thicker with the steel. It's drawing too much heat out of it. But I'll go ahead and I'll cut this, and I'll cut it further back as well, just see what the penetration's like over here and in the stop start that I've done. So there's my stop start. It could have come back a little bit more. Other than that, I'm quite happy. A nice even profile, not undercutting. On this side it's very nice and even, but you can see that bulbous side, it's not penetrating in as nicely as this side is, I don't think, but we won't really know until we've cut it. So that's what I'll do next. Okay, so while this is cooling down, let's weld some sheet metal together. So I've got these pieces. You might recognise the kind of style from one of the previous projects. I thought, wouldn't it be a good idea to see what this is kind of like on the kind of things that we're going to be getting up to in the future. So I think a little kind of butt weld on the end, corner joint might be quite ideal. Where's a good place? Maybe like that. So I'll prep this side as well, and then we'll see if we can get a nice bead on it. So I'm going to do some presets on this piece of scrap here, just run some beads across, see what the penetration's like, give it a good listen to, and then we'll tack this up and do the same on there. So for this I'm using 0.6mm wire. I've changed the nozzle to suit, and I've put it on 2 on the wire feed and 3 on the power. So I'll check to see what voltage and amps that's reading. A bit more wire feed I think, so maybe 3.5 wire feed. Let's see. Maybe a little hotter, maybe 4 and 4 maybe. Turn it up to 7 and 6, see what that's like. So that's a nice string. Still very bulbous. Let's see if I can penetrate it. Why don't we go to 9 and 8. That produces a very clean bead. Now that's penetrating in nicely, and I suspect there's a bead on the other side. Yep. So there's good penetration there. That's a better profile. Wonder if we can get some spray transfer. There's a lot more wire for that. Nope, on max. Keep it up nice and hot just for tacking to start with. And this is another reason why having a MIG welder is good. It's tacking far more easier when you've got all these fiddly pieces to do. Put the filter on. That, I think, is a fairly neat bead. Maybe could have done with a little bit more wire feed, tiny bit more amps. Got some penetration coming through there. That to me would be ideal. That's a very neat, fine weld that you could easily dress back. Yeah, a little bit more playing with the settings on that, and I think that would be a good one. Okay, so I've cut the test piece open, and I've just given the one side a nice little sheen, you can see there. So let's zoom in and we'll have a go at acid etching it and just see what the penetration is coming up to on that maximum setting. So if I get some of my acid etching solution out, always be careful when messing about with acids. Rinse that straight away. So a don't know if you can see that. It might be hard to see, but up close you can see on this side it's not even, there's a tiny little gap there, and that's because that weld is simply sat on the surface. That's not actually penetrating at all. This was with the kind of like 8, as it said on the power, maybe 9 or 10 or so on the power, on the wire feed, and there is no penetration in there at all. This side, however, with the spray transfer, you're getting a little bit. You're getting the root in there. So the root is definitely penetrating. The rest of this isn't so much. So I would say with this machine, maybe 6mm is your maximum you can weld with to get a decent weld. I mean, it looks, you can say that that looks like a nice weld as far as the profile and everything goes. Certainly that looks like a nice weld as far as neatness goes. But that is an inadequate weld. That weld will break. This weld is better, but I would like more range in it. For a MIG welder, that's what I would prefer. But then again, I'm not using this machine for anything thicker, really, than 3mm. And this has produced some lovely results with a 0.6 wire. Okay, so let's finish with my conclusion of this machine. Am I happy with it? Now, I think you've got to start at the price point, so 300 quid less, including free shipping, I think is absolutely phenomenal for the performance that you're getting. Now, you could actually get spray transfer out of this, but the biggest questions for me is having a 3-pin plug. I mean, very fortunate in England, we have fuses into our plugs. So if you blow a fuse, you can just simply replace the fuse. You haven't got to worry about circuit breakers or anything like that. But if you're going to use the maximum settings, you can't use this plug. It's absolutely useless. So you'd have to chop this off and put either a 32 or a 16 amp plug on there, and have the correct breakers over in the circuit breaker. So I can't really test to see if the duty cycle is actually any good. It says it's 60% duty cycle, which is very high, very standard on most good quality machines. So for a cheap model, for it to be that high, it raises some eyebrows. So I can't really comment on the duty cycle. Things that I am disappointed in, I'm disappointed in the literature, I'm disappointed in the safety warnings that are on these machines. It also says that there is a helpline for Rohr that you can call. Now, I can't find a website, and they haven't supplied me with a phone number. So all of those are a bit alarm belly, if I'm honest. They do have a phone number for the company that is selling the machines, so it's not Rohr, they are the brand, but the actual sellers have a number that I can contact. But when you look at the build quality and you look at all the parts in there, it's standard off-the-shelf bits. So I'm happy that I can actually be my own insurance in that case and fix it myself. As far as Amazon goes, the warranty on that, I'd have to take it up with Amazon if there was any serious issues, I believe, rather than going to the seller. I think Amazon would cover you better. But it does come with Prime, and they do have this warranty and stuff within the literature. So you've got some sort of a backing, and Amazon are pretty good at backing people in that case. I was hoping that Rohr, being such a strong brand name, and they've got it all over there, and it's very distinctive, set apart from the rest of the crowd. Now, the thing is with brands, they like to have a quality. They're making a name for themselves, so the quality and the customer service should be there. But we're obviously not paying for that with Rohr, so you're literally getting a brand and nothing that comes with it. But if you were to buy, say, from Lincoln Electric or Miller or Kempe, as I've said before, you get that customer service, you get that guarantee and customer satisfaction to go with it, because they've got a brand that they've been building for a long time and want to keep it. They want to be the leaders within their industry, but you will pay a premium for it. So for instance, what did I look at? The ESAB Rebel, which is their kind of standard line at the moment, the ones that they're pushing most of, the equivalent of machine, if you like, as far as what the specs say, they are £1,300 plus shipping, plus VAT, I believe. So you're instantly talking at least £1,000 more. So that you've got to equate what you're going to use your machine for as far as the profitability that you're going to be making for that kind of a cost. If you can do the same work but spend far less, you technically make more profit. But if I was MIG welding day in, day out, with various different thicknesses of material, I would first of all be using a 3-phase machine on an industrial unit, because I then got the full range of settings that I'd need. As far as mid-range brands go, I have used Artec. Now Artec, I would say, identical in quality as the cheap machines. But you are paying them for customer service, and so they are again a brand that I can contact. They're actually very local to me. I could actually drive for an hour and go and meet them and get spare parts and all that kind of things from them. Obviously I can't do that with Rohr, but you're paying at least double again. You're paying a lot more money, but it's whether that money is worth it to you. But anyway, watch this space. Happy forging a life worth living. See you in the next episode. Bye bye.